with these things?
So yeah, let's talk about asset tracking. First of all, I'm pretty sure that everyone is familiar, but I just wanted to to make sure that we are all aligned. So asset tracking provides real-time data on different assets that company owns and how these assets are used. In most of the times, these are moving objects. So they are somewhere in the wild. They are transferring certain, sending certain data. But the whole idea is that for the business owners or whoever is kind of involved into this, to get a full understanding of what their fleet is doing and how they are performing or how they are not performing. So all of that. For that, we need certain connectivity. We need certain data that comes from the devices, from the vehicles itself, of course. And of course, the major data, the basic data that we get is the location coordinates. But then we can layer all sorts of different data on top of that. So this is, and of course, a remote control in the cases where it's needed. So basically, this is the asset tracking. And this industry is already huge and it's already growing. That's why I think we're talking about it today. So as you see in 2020, it was 17, like more than 17 billion. And it will almost double by 2026. So this market is growing. There's a lot of opportunity for businesses and for developers as well, because you will be involved into building solutions like that. And that's why we are, I think, talking about it today. However, there are still certain challenges in this industry. First of all, even in despite that the fact that hardware is getting a bit cheaper each year, the tracking hardware is still pretty expensive, and I think that it also affects the adoption of the solution. But even on the higher scale, the cost of fleet management software is pretty expensive as well. So the prices for software to manage the fleet of devices, to build things, is still very expensive as well. And this is another factor that where we can work on and kind of think about how we can face this challenge. And the third thing that we see at Blynk, because we work with a lot of companies on the market who build IoT solutions and asset management as well, is that off-the-shelf solutions are limited. So there are just a ton of options on the market right now. You can buy a GPS tracker and then you will get some software around that. But if you want to step any further and maybe modify the functionality or add additional features to the app or to the hardware itself, to the firmware, then you're really, really limited to what the provider already built. And this goes completely against what Blynk is made on. So we are promoters of hacking things or improving things and building something that you own and that you want to kind of, you want to bring your own ideas into that. So that's why we built the platform in the beginning. So we allow developers all over the world to build their own IoT solutions, but focus specifically on like the features that they want to build and not be limited by other factors. So everything on Blynk is very, very customizable. And you'll be seeing it today. So yeah, basically these are the challenges that we will be trying to solve today. So let's challenge them. So for our today's workshop, we chose we chose the hardware which is called Particle Tracker 1. So this is a ready-to-use device. It's sold by an American company called Particle. I'm pretty sure many of you heard of them because they are known for Wi-Fi and cellular chips and Bluetooth. Yeah, some of the Bluetooth chips as well. But this is kind of a complete solution. What we like about this one, while it has its own cons and pros, but it's hackable. So you can write your own firmware that runs on the device, and it also works out of the box. So you can take it and out of the box, you can start getting certain data from the device and you can start building around that. Blynk works perfectly with Particle hardware since day one. So there's like a lot of opportunities there. But it also, the device by itself is pretty interesting. First of all, it's based on the ARM Cortex-M4 processor. It has a lot of stuff on the board. It has Wi-Fi, Bluetooth, cellular connection with an eSIM, so you can reprogram it remotely. It has real-time clock. One of the nice things that it has CAN bus connector, so you can connect it either to the vehicle itself and process the data from the vehicle and send it to the cloud. It has buttons inside. It has battery. So it's kind of a pretty self-contained device that you can just take and use. Moreover, Particle offers over-the-air updates, which are crucial for any IoT development. And as I said, the biggest kind of plus for us is that you can write your own firmware. So they provide you with the source code of their firmware, and you can modify it and run your own code. Particle also offers tracking services, which kind of something they call Particle Console, where you can do some basic things. And while it's great for the proof of concept, just to get the data flowing in and out, in order to build something, you need to do a lot of development. If you need a mobile app, you need to build the app from scratch. If you need front end, then you need to build front end from scratch. So they provide an API, but there's still like months of development to build something that's commercially usable. And we still believe it's a good starting point to get the things kind of learn a bit about the hardware and beyond. But then, and as long as you need to move anywhere further, you will be very, very limited by what they offer. Alternatively, for this workshop, Volodymyr built kind of a hack together little device. Maybe you can tell a bit about what's there, Volodymyr?
Sure. So actually connecting the particle tracker to Blynk was really easy. So I thought it's like not worth the whole workshop. So I just took something I had lying around. This was particle Boron, which is a really good piece of hardware. Also, like it's a particle device, so most of the infrastructure or like tools that we'll be using today are also applicable to the particle Boron. This one is cool because it also has cellular connectivity, which is really like it's a nice feature for any kind of trackers because it doesn't require local like networks. It's working over cellular, and yeah, well, basically I just hooked up GPS receiver. And I wrote a small firmware which I'll be showing to you today, which uses Blynk services directly. For particle tracker, we'll be using the ability to integrate via webhooks. So that's the idea.
Basically, the difference is that the tracker one, which I have right here, is working out of the box, so you don't need even to modify the firmware and it will work. While you can also build your own device and connect all the peripherals you want, whether it's a sensor, like a temperature sensor, like any other sensor, except for in addition to the GPS, and then you can use it in your solution, in your asset tracker solution. So I briefly touched the software already, but as we are presenting Blynk, we will be showing you how easy it is to build an asset tracking solution with Blynk. And I hope that at least some of you already know our platform. We've been here for around 6 to 7 years. I don't remember exactly, around, yeah, 6 to 7 years. And we've gone through a lot of transformations. We recently launched a new platform, and it kind of has a lot of new functionality. But on a high level, Blynk consists of 4 different components that you see on the screen. So first of all, we have the firmware, or like an agent or a library that runs on the device. And we support over 400 different microcontrollers and single board computers that you can use out of the box and run Blynk on there. So this library will manage all the connection of the communication with the cloud and all sorts of like device authentication, over-the-air updates, and all different things. Of course, we have the cloud. So basically, there's a free cloud for any developer that uses Blynk Platform. You don't need to run your own server. You don't need to do anything. You can just create an account, and the cloud is ready for you. It's in different regions, so it's ready to accept in a number of your devices. You can scale it up, and it's a secure, reliable cloud. We've been up and running for 6 years without no major shutdowns at all. So it's a good one. So you should definitely try it out. But I think that this is like something that almost every IoT platform has today. You have something to send the data, and you have the cloud where the data is being processed. But the major focus of Blynk is on the building an application, and we have two different products for that. So one is the mobile application builder, which is a drag and drop. What you see is what you get. Very, very easy to use, no coding at all. Mobile application constructor, where you just drag and drop the bits of interface that you need, like a button that turns something on and off, or a chart where you plot the data, plus notifications, plus events, plus all of different functionality that you would need for any IoT project. So this is the mobile application builder. And then we have the Blynk console, which is on the one side is a web interface to visualize the data from the devices, similar to what the mobile application does. But also it offers a lot of functionality in terms of managing your devices. So once you go beyond the stage of development, you need to manage the kind of hopefully millions of devices. So we are fully ready for that. We have a multi-tenant structure. I'll be showing you a bit later today. So yeah, basically it serves two functions. On the one side, it's just kind of access to the device data. On the other side, it's a management platform for whether commercial or private application of the Internet of Things. And today you are lucky to witness the first time demonstration of our fleet management solution. So this is kind of an additional, like you can call it an add-on or a plugin that works on top of Blynk, which is specifically designed for fleet management. So how to manage moving objects, what you can do with that. We have a separate drivers app, for example. We will not be touching it today, but overall, this is something that we will be showcasing for the first time. So congrats on that, everyone. I hope that you will like it. But let's get back to the workshop. So our mission overall is to make Internet of Things simple and affordable for businesses and developers. And we already talked a bit about the price of the asset tracking solution and why we think it's crucial to lower the costs and democratize this solution. Let's look at some like numbers that we found already. So if we're talking about the fleet of, let's say you have 40 vehicles, it's a kind of a medium-sized business. Maybe it's a logistics company, maybe it's some delivery company, whatever is there. So on average, if they go on the market, they would need to spend somewhere between $8,000 to $20,000 just on the hardware itself. So the hardware is pretty expensive. And to manage that, to oversee the fleet of devices, first of all, I need to mention that we're talking about more or less kind of industrial equipment. We're not talking about like a simple GPS tracker for the car. We're talking about something that's used commercially with a more functionality, a bit richer in reliability and etc. So on the software for to manage such fleet, you would pay somewhere between $15 to $300 per asset per month. So the cost of the company, the expenses of the company for that can be very significant, from $600 to $20,000 per month. Plus, if we are talking about some development time, this is also, it has its own costs. I didn't kind of got into the equation here, but still, there's something to consider. Time to market, implementation, integration within the company, all of that also takes time, resources, and its expenses. So with Blynk, and in particular, today's example in Particle, you would spend about $6,000 on the devices itself. They are pretty affordable. $159 for a device in the case that kind of ready to use is pretty good. And the best part is Blynk. So on the software, a company would spend around $49 per month for the 40 assets already. Of course, if you scale up, that will be this price will increase, but still, it's nowhere near to $600 to $12,000 per month. And if you are building a solution from scratch, then you would save on we estimate that the savings on development time are somewhere between 6 to 12 months. So it's just a huge amount of saving for the company. So yeah, let's yeah, let me know if there are any questions. I'll try to look into the chat from time to time, but I'm on the keynote, so I won't see anything straight away. So, but let's move to the workshop. Let's actually build what's the topic of today's workshop. So let's look at the Blynk setup. So how things are done. So I would need to switch to a different screen. Let me stop sharing. I will start Chrome tab sharing, Blynk console. Before we get into the specifics of how things are done, let me just briefly give you an overview of Blynk Platform. So we have, we're currently looking at the Blynk console, which is a web application, and we have lots of different functionality here. But the main thing is that we're looking at two devices that we've built. One is the tracker, the second one is that Volodymyr showed you. So if we open the device, we can see the data from the device. I will put it full screen. So we show real-time data, we show historical data, we can see the GPS track, we can maybe check yesterday's GPS track. We can do also a lot of different things here, but that we can that we'll be showing you. We can also log different important events in the device. We can get the device information. We can attach pieces of data to the device. And some other development tools that I will be talking a bit later on. So this is one device. This is the second one, which is the Boron tracker. Today we have some track here as well, and we can do certain overlays. For example, we can take it the speed gradient. And all of that just works out of the box. All this is customizable, configurable. You can build your own dashboard and build your own application. So, but let's go into how this was created, basically. So we prefer building it from the top to bottom. So first of all, we need to define what the user interface should be, what the application should do. Of course, you start from the requirements, but once you get the requirements, let's say we want to show the actual track of the device. We want to show additional data from the device, and we need to visualize it in different ways. So for that, we work with something that's called templates. So template is a model of the device that can be applied to all devices of the same kind. So we have the same, think about it as a product. So the product performs certain functions, and if you have, in our case, like 40 units that we need to kind of configure, then this template will be used to configure all these 40 devices. And when we do any changes to the template, then all these changes are reflected on all of the devices without any like republishing, firmware updates, or anything. That's UI is here, and you can do over-the-air updates as well. So yeah, we have this. This is the template that we already prepared for you. Because it's easier rather than doing it from scratch, it's easier to show you what's there. So there's a bunch of settings, general settings on the device. Then there's the metadata. The metadata is kind of a table of key value that you would like to assign to every device. For example, if we need the serial number to be placed somewhere in the system, then we create a new metadata field. We call it serial number. We can do certain validations of this field if it's needed. And then basically we will be able to add this information, whether from the device or by user input, whatever is necessary. So there's an API for that. The most interesting tab, I think this is this one, it's a data stream. So data streams are designed to define the data that flows in and out from the device. So in our particular case, we will be sending the location data, altitude data, temperature, and speed. So you just create a new data stream, and and then you just set it up, like what's the name, what's the minimum maximum, what's the format, and all sorts of different things that you can do here. The next thing is events, because when we're talking about IoT, it's alert is a kind of a crucial part of any IoT application. So end customers should be notified if something goes wrong. And at this point, you should define what is important for this particular use case. For example, here, just an example, as an example, I created 3 types of events: high temperature, high speed, or rapid acceleration. So if like the device kind of accelerates rapidly, those people who need to be notified will be notified. And we'll be talking about notification management in a bit. So yeah, these are events. They can be logged. You can assign notifications to them. They can be sent to the mobile app. They can be sent to the web console. They can be sent over SMS. So there are just different ways of doing that. Web dashboard. So this is the constructor where you just drag and drop different widgets and you configure them. I think that map is kind of a very good example. Like if you go to the settings, there's a ton of settings here. First of all, we are specifying where we need to take the location from. We say that if there's no location data for 10 minutes, for example, we need to break this track. We show direction. We can specify what goes into the call out of the point when we hover it with the mouse. This is an interesting part. This is the track overlays. So it's you will never see it usually out of the box on any platform. So you can specify different overlays on the track. So for example, for the speed, you can set the gradient and then set the kind of how this gradient is distributed on speed. We are talking kilometers per hour. Sorry, we are from Ukraine originally, and from Europe we will use a different metric system than in US. You should too, by the way. I think that everyone should use the metric system. Or we can overlay temperature data if we have it, and then if it's a kind of cold truck or chilling truck, then we can see whether the temperature goes beyond a certain threshold on the way. So this is something that works out of the box. So you don't need to spend like months of development by building your own map with overlays, using third-party libraries, integrating all of that. It's literally months of work, and everything you can just do here. There's a bunch of other settings that you can use. Basically, then we create the dashboard for the device. I don't want to edit it. Yeah. So the next thing is interesting that I already mentioned that Blynk offers the mobile dashboard. It's something that you don't build here. You use your mobile phone for that. I will just briefly show you how it works. Let me check one thing here. That you can see my phone right now. Can you? So here we can, this is the mobile app. So currently we're looking at the user point of view, and it's already like a ready to use app, right? So we see both the devices. I can go to any of them, and we already have the dashboard for the device. The best, I think that we took this approach of separating the mobile app dashboard from the web dashboard is that the screen is different, the functionality can be different. There can be other people who are using the app compared to those who are using it from the mobile. Maybe management team, sorry, from the web. The management team may be sitting in the office behind the desktop computers. They will be using the dashboard, while someone in the field, like a driver, for example, they will be using the mobile app. And so you can create different dashboards, or you can create them in very, very similar as well. So the creating mobile apps is super, super simple. So if I go to the edit mode, I instantly see this kind of drag and drop thing. So yeah, what should we do here? So we have a bunch of different widgets that you can use. For example, if you need to send certain data, I can add the slider widget. Oh, it's added at the bottom. Just give me 1 second. Leave some space here. So you can add a slider. You can resize it as well. It's very difficult at the bottom. Just give me 1 second. slider, I can go to its settings. I can set up that it controls something. In our case, we don't control anything with the slider, but yeah, this is very easy to do. So you can drag and drop different widgets. We have a ton of them. Blynk is a multi-page app, so you can create additional pages and call them from the app as well. And each page can have its own set of widgets. This app also covers the provisioning process, which I will be showing you. Provisioning is a way of adding new devices or provisioning new devices. So yeah, there's a kind of ton of features that you should try out. Like here, we're looking at simple label widgets and some of the buttons, and everything is customizable. You can use your own images. Yeah, you don't need to know the Xcode or Android developer. You don't have to be a mobile application developer. You can just build a very decent UI with this app. So yeah, I don't even know what to add here. Yeah, like showing you multiple, multiple pages here. This is a very weird chart from the device. So yeah, you have multiple pages, very nice looking mobile app. By the way, it can be branded and sold as your own app. So you can publish it to app stores or Google Play with your icon, yeah, with your icon, a company name, and with your description, and nobody will ever know that it's Blynk running underneath it. So this is the app, but okay, this is great. So kind of I hope that you have an understanding that it's relatively, or I would say like actually really easy to set up the project and to build a UI, which will be enough for the proof of concept or even for final product. There are hundreds of companies who are using our solution and build actual commercial solutions with Blynk. So we believe that it's definitely usable for commercial use. But we need to send the data. So this is the next part that Volodymyr will be covering. I will stop sharing. So yeah, in order to populate all these widgets with data, with location, with the temperature, with speed, we need to send it from the device. And I think that this is what you guys will be mostly doing, because everything else is just super easy. So you can build an app in a day, and that will work. Okay, so you are sharing. Yeah. Okay.
Yeah. So basically, as we're using the Particle device, Particle has built a whole ecosystem behind the devices. So they provide ways to add devices to their platform. They provide API to, like on the device, they provide API to connect to different services and stuff like that. We provide basically a library which allows to connect any Particle device to the Blynk platform directly. So I'll be showing, first of all, when we got the Particle tracker into our hands, we were looking into like ways to extract data from the Particle tracker and to get it to our platform. It appears that Particle has built some really nice features to achieve that effortlessly. Like first of all, Blynk allows you to get data from the HTTPS like requests, and also Particle Cloud allows you to set up integrations and webhooks for like to basically send data to some third-party services. So we'll be using that for the Particle tracker one. But currently I'm looking at the devices view. So whenever you open the console, like on the particle.io, you'll see a bunch of devices that are like that you possess. And basically two devices of interest are currently assigned to me. One is of like asset tracker, and the second is the Boron. I'll be looking at I'll be looking at the asset tracker first. So this one provides quite a lot of different info about your device, like its health information, and allows to send some commands to the unit. It also, like from time to time, the unit is publishing some events to the Particle system. You get to see a live view of those events here. You can even like dig into the data that is sent out of the devices. This one was used to better understand the structure of the data that is sent by the device. We'll need that knowledge later on. But overall, this is really nice view for the integrations, and specifically for the webhooks. We had to navigate to the product section and create a new product and use a tracker one device for this, basically add the device to this type of product. Then we basically all these operations are pretty much covered by the particle docs. They are pretty nice. And once you get that, you can see the simple dashboard that is provided out of the box. But also there is like a lot of buttons here on the left that you can use to navigate to other parts of the particle infrastructure. Well, basically it contains a lot of interesting stuff like firmware management. For this one, for example, you can see that the product is using the latest Tracker Edge. Tracker Edge is a default firmware for Tracker One device, which is shipped with the unit, and you can update it effortlessly right from the web. So they provide all of the OTA updates to the units, also the system, the OS of the particle device is also updated along with can be configured to update along with the regular firmware updates. And we are now interested in this integration part. So you can add a new integration, which we did. We select the webhook type, pre-configured, basically webhook. The webhook is triggered by an event which starts with LOK, like location. All of the events with this prefix will be also transferred to this kind of URL. A URL is we are sending this data to a Blynk system, and we use our API specification to format the data in a specific way so that Blynk Cloud understands it. Once we edit the system, you can see that this kind of URL is also combined with some of the data from the, whenever the location event is published, it also contains some data in it. And this payload contains a JSON object, which is decoded. So we take location and then longitude and latitude from that and just send it out to our system. We also extract altitude, temperature, and speed information from this device and assign them to different data streams, which we use virtual pins currently on our system to bind this information to some specific data streams. So that's how it works. Once we have configured it, we just save this. I'm not going to edit it, but overall, once you save this webhook, this is automatically activated. And whenever your unit is publishing the data, it's also transferred to Blynk. This page also contains some kind of nice charts about, basically success rate of these requests and stuff like that. It's very informative. Once you have configured the webhook, actually, if you see if you go to the Blynk Cloud, there is one particular missing part of information that I didn't mention before, is that when you transfer data from Particle Cloud to Blynk Cloud, you have to somehow identify the unit that is producing this data, right? So we use this, if you go to the device information section, you'll see some of just the code snippet, which also includes a Blynk authentication token. So this token is used to identify this asset tracker unit on our system. But on particle system, you basically have these instances where the device instance is identified by device ID. Currently for this demo, I just basically hard-coded the device, the authentication token into the URL, but we have also ways to bind it dynamically via the static authentication token management subsystem that Pavlo mentioned. So this one will transfer all of the data to the specific unit on the particle. Just a second. And once we start getting these requests on the system, the data is published and displayed in real time on the charts and on the map and in the widgets. So that was really simple for the asset tracker, but for Boron tracker, it was also rather simple, I'd say. So once I built the device, the Boron tracker, where is it? So once I have finished building the hardware connecting to the GPS module, I had somehow to get the data from the GPS module and then somehow to transform it, format it, and to send out the Blynk platform. So I'll show you how that was done. We'll be using the web IDE of the particle system to achieve that. Again, I'm just taking the Blynk library that we mentioned before. And actually, this is all the code. I mean, this is it. So I only had to take the Blynk. I also had to find some kind of a library that parses NMEA codes from the GPS module and extracts the meaningful information out of it. I also found
maybe you can explain in a second, what Blynk Library does.
Sure. So first of all, this is basically very simple very similar to a simple Blynk example that is provided along with the Blynk library. Blynk library is managing the Cellular, basically the connection to the cloud. It connects directly to the Blynk cloud, and it's responsible for all kind of heartbeats, formatting the packets, sending out to the Blynk platform, also receiving some of the metadata. So it contains a bunch of APIs, which allows you to integrate into Blynk applications and web dashboard easily with any platform. So this is available for Arduino, for Particle, and for bare metal systems as well. Currently, we are using the Blynk C++ library, but you have some kind of libraries for different languages as well, if you need that. So I'll focus on this. Basically, you just need to call a few simple Blynk APIs to get connected to the cloud. For this one, we'll use the same kind of information that was, let me show you once again, if you go to device info,
because it's so small on the screen.
Sure. Okay. So if you go to the Boron tracker, you'll see this kind of snippet, and this is a device configuration which you need to paste into on top of your code, and then you basically use the Blynk library. You just initialize it using the authentication token, and you need to Blynk to run Blynk from time to time, so it performs all of its bookkeeping and heartbeats, parsing the several replies and stuff like that. So beside that, we'll need to somehow use the GPS library. I'll show you a simple example. So here we use we transfer data from the GPS port, which is serial 1 on the particle system, to the GPS library. And GPS library is actually getting these NMEA codes from the GPS port, which looks something like this. And I just found some tool on the internet that parses them. So if we click parse, we'll see some kind of information of these the codes that are sent by the GSM model, by GPS model. So this is basically the same stuff, but this is managed by the GPS library, which is now GPS. Now, I'm just using the GPS library APIs to extract the longitude and latitude from the unit and send it to the V1 data stream on the Blynk cloud. So Blynk Visual Write is used to send out the data from the unit. And that's it. We'll just send out the altitude, speed, and that's it. So after we upload this code to the unit, we can go to the to our dashboard and see everything's like all of the information here. Yeah, I think that's it.
Thanks. So yeah, basically what Volodymyr, I think that the whole idea is that there are multiple ways to approach the building of an application. And it's always up to you to decide whether you would like to build something from scratch, of course, or use a platform but from what we've seen, it's really, really beneficial to use your time effectively and use the tools that are available, hardware tools and the software tools as well. So we believe that it's very, very easy to build an asset tracking solution using good hardware and good software. And I hope that we showed you how easy it is to build. The only thing that I wanted to mention is that the product life cycle doesn't stop when you build when you wrote the code and you wrapped it and deliver it. There's a lot of, like, actually this is where the product lives begin. And there are a lot of things that you would need to think about, starting from how your customers will be activating devices, how they will be grouping them, how they will be managing them. So there's just a lot of use cases that you would need to think through. And we already did part of that. Currently, Blynk solves around 90 to 100% of the use cases of any IoT solution that you would like to build. Of course, there's always like a space where constructor doesn't solve it, but we provide tools for you to build on top of that. So I think that, yeah, this is what we wanted to show you today. It's really doable to build an affordable asset tracking solution, which is commercial grade and ready to be used by an organization. If there are any questions, we'd be happy to answer them. We are already out of time, but I think we'll find a couple of minutes for your questions. Yeah, the chat, I believe, in the bottom to pose them. Reading, okay. Question. Currently, so there was, I don't know if everyone reads the chat, but if I summarize it, then in our example, we show the Cellular connectivity solution, which is used in like 99% of the asset trackers applications today. There's of course LoRa and other stuff, but let me check. Michael is asking about whether it's possible to use Blynk application which connects over Wi-Fi to the module, and then we use the mobile app as a gateway. So currently we don't have such solution. However, it's a really good feature and it's already on the roadmap. So we are considering using Wi-Fi or Bluetooth connection and then using the Blynk app as a gateway, by the way, in different use cases, whether it's just streaming the data or grabbing the data or harvesting the data and then uploading it to the cloud in batches when, for example, you don't have internet connection currently, but then the truck arrives at the location and the smartphone connects to the Wi-Fi router, and then it transmits all the data that was previously collected throughout the route. So we don't have it right now, but we are working on that. Okay, next question from Dara. What about eSIM and using that of dynamically registered devices and mobile carriers via framework? So we currently have an integration with Once, company called Once, One NCE. They provide a really affordable SIM cards and kind of connectivity and data packages for IoT. So with them, you can just register you can enable integration on our side, and then you will just enter the SIM card number and the device will be registered. So this is something that we already have. I understand that your question is regarding eSIM. Volodymyr, maybe you can expand on that because it's more something that you know better. So is it possible to dynamically register devices with eSIMs?
So right now we, like for cellular connectivity, we provide a special method to bind the physical units into our cloud. This is performed by like QR code scanning. So if you're using the like one NCE like Paul mentioned, then you have some kind of built-in support in Blynk to do that. If you're using, for example, particle devices, then they provide their own system to manage the SIM card configuration. But if you're using third-party SIM cards, you'll have to use the static token management system to bind, to basically create all of these QR codes. And then, yeah, I mean, Blynk provides this method just to cover all of the other cases where we can bind this information. Anyway, like if you think about managing the payments like card balance, so this is covered by Particle, One and CE respectively. But if you're using your own SIM card providers, then you'll have to kind of manage it yourself. That's it.
We have a mechanism of mapping unique IDs of the SIM cards to authentication tokens. Like Blynk requires authentication token. This is like an architectural platform. But we build a tool where, let's say you have a list of all the eSIMs that you have, because you buy them, you definitely have them. Maybe you can reprogram that, but still you have the what's called the IMEI number, something like that, the unique identifier of the SIM card. So you can take this list and create a batch of tokens on our site. So you will upload the CSV file, and then it will be mapped to all of the to authentication tokens, and then you can use the eSIM unique number in order to activate the device. So basically, this use case is covered basically. Be dynamically handled on the software. Say the device just needs to check in once a week, but you should unregister and re-register on the operator when it's needed. It's an interesting case. I don't think something like that. So basically, are you talking about? Are you asking about the methods of saving on the data so that you just kind of unregister the device when it's not needed? It's an interesting case, but I don't think we have like an automatic solution right now, unfortunately.
So Particle has some kind of system to put SIM cards on pause and stuff like that, so you can manage it through the Particle system. If not, you can use yeah.
Do that.
I see.
Yeah, we can chat in the lobby as well.
Anyway, I mean, there are systems that allow to do that. Blynk doesn't provide any specific way to do it, but you can always include, you know, a physical button or just a logical button to turn device into different modes. So like power saving or the data saving modes could be implemented and stuff like that. So it depends. And also this could be a remote command that triggers device into different modes. Like you can manage the timeout or the interval during which the data is reported, right? So that's how we do it.
For one's SIM card, they have a data package which is like 10 gigabytes, and it doesn't matter like the timing. They don't charge you monthly. They just charge you for the pool of data. And by the way, this pool can be distributed across the devices. So in this manner, there's no actual need to switch the SIM card on and off, to deactivate or activate it. All you need is just to manage how often the device sends the data. And you can build your logic by writing your own firmware, like whether it's interval, whether it's an event-based, when something happens with the device that sends the data, something like that. So there are multiple ways to approach the same use case from different angles. Yeah. Any other questions, guys? Well, I hope that this workshop was valuable for you and you learned something new. and they learn that we can. There are ways to simplify the application development for the asset tracking industry, and we hope to see some innovative solutions out there in the market very, very soon. And please make it more affordable so that more and more businesses can use it. There are all sorts of ways to do that. Let's work on that together. We'll be leaving the stage. We'll spend some time in the lobby in case you'd like to chat. And go to blynk.io if you have more questions. We have documentation. We have amazing community of developers like you who are eager to help. Forum community.blynk.cc. So you're very welcome, and see you soon then. Thanks.